All right, now let's look at a function where we have multiple transformations all going on at the same time. And I still have the table here for reference, but we're not even going to use it in this particular case, except for those values that you can already see here, and we'll just kind of go from there. So let's go ahead and dive into this. If we want to figure out our transformations, I always start with the horizontal transformations first. And so that's going to be what's being inputted into our square function here. So let's go ahead and find our horizontal transformations. Now the x has a 1 coefficient, so it's not being sped up or slowed down, so I'm not going to have a horizontal shrink or stretch. However, I am subtracting 2, so I will have a horizontal shift. Now, once again, I want a 0 input because that's where I normally get my vertex. So I'm going to go ahead and just figure out when x minus 2 is equal to 0. So that means that x equals 2 is going to be my new vertex. So I have shifted 2 units to the right. Well, let's move on to our vertical transformations. Well, I have this minus 3 that I'm multiplying by my parent function, so that's going to speed me up in the opposite direction because of that negative there, right? The negative will make everything opposite. So I am going to have a vertical stretch, and that's going to be times negative 3, about the only time you'll ever see me use an x for multiplication. All right, now lastly, we have one more vertical change, again, because it happens after the square function. And so we need to ID that as well. That plus 1 is going to shift everything up 1 unit. So I've identified all of my transformations, but now what order do I do them in? Well, as it turns out, we do them in the same order that we would calculate this out if we plugged in a number. So let's look at that. So going through the order of operations, the very first thing we would do is to subtract what's inside the parentheses here. So that's step 1. The next thing we would do is to square it, but that's the parent function, so that's not going to be one of our transformations, but we'll do it just the same. After that, we would go ahead and multiply by the negative 3, so that's going to come second, our vertical stretch. And then the very last thing that we would do is to add that 1. So that's going to be our last transformation, our vertical shift. And again, this value isn't particularly important here, but let's go back and actually identify the order we're going to do this in. You'll notice I already put it in the correct order, but we had our first transformation was that horizontal shift, so we'll do that first. The second transformation was our vertical stretch, so we'll do that next. And then the very last transformation was the vertical shift, so we'll do that last. And what we're going to do is we're going to pick, I generally do about 5 critical values to perform these operations on. So I would just pick those values in the middle, and I would start at 0, and let's do, the ones that I already have graphed on there, if at all possible. In this case, we're not going to be able to fit most of these on the graph, so we'll just kind of do our best, okay, and work our way through. So let's take a look. We're going to start with the origin, or our vertex, okay? So we start here at 0, 0, and then we're going to go 2 units to the right, so 1, 2 units to the right. Then we multiply our height by negative 3. Well, we're at 0, so that's easy. And then lastly, we're going to shift up 1 unit. So we wind up just right here. So there's our vertex. Now, I'm going to do the next one with the actual coordinates, the points, because I think that'll illustrate it a little better. I didn't want to do it with the vertex, though, for fairly specific reasons. But I'll pick this point right here, the point 1, 1. So we're going to shift 2 units to the left. So that's going to affect our x here. We're going to subtract 2 from it. And that gives us the point negative 1, 1. Then we're going to move on to vertical transformations. So the x isn't going to be affected, but I'm going to multiply my y by -3. And that gives me the point -1, -3. And then the very last thing we're going to do is we're going to shift up 1 unit. So I'm going to add 1 to my y value. Okay? And that gives me my new point. So this point right here, okay, we took it and moved it 2 units to the right, then multiplied that by -3. So the 1 became a -3. So I was down here now. And then I shifted it 1 unit up to -1, -2. Now, because of the size of my graph, I can really only do this for one more point. So I'll do it for this one here. I'm going to shift 2 units to the right. Then I'm at a height of 1. I'm going to multiply that by -3. So that 1 becomes a -3. And then I'm going to move it up 1 unit. And while this is less points than I would really want, you can clearly see that our graph got stretched vertically, got a bit skinnier, and was flipped because of that opposite stretch, and was shifted 1 unit up. And you can see that real clearly here in the vertex. For a more accurate graph, you would probably, again, want about 5 critical points as opposed to the 3 I did, but because of size constraints, this will have to work well enough. The last thing that I want to mention is that for all of these, I used the same parent function. But the great thing about this method is it works for all functions. So if you can master this method, you don't have to worry about changing it up when we have a parent function such as p of x is equal to the absolute value. If we had the absolute value function, any of those parent functions I showed you at the beginning, or any other parent functions in existence, you'll be able to graph them by identifying the transformations in the exact same way that I just showed you.